In this video, I'm going to cover the difference between how different nucleophiles react with alpha-beta unsaturated carbonyl compounds. So I have an alpha-beta unsaturated carbonyl compound here, and I've numbered the oxygen 1 to the double end of the double bond here 4. All right, so it's an alpha-beta, so this is alpha. The alpha 3 is alpha to the carbonyl carbon, so the alpha-beta unsaturated, the double bond carbonyl compound. All right, some nucleophiles are going to add, like we've seen previously, and do a 1,2 addition, which is the normal type of addition that we've seen. All right, so what we'll get for the product for a nucleophile attacking at the 2 carbon is going to look like this. I'll get an O minus. That nucleophile will come in. I'll still have my methyl group on here. And then after I treat this with acid, I'll protonate to get the alcohol. All right, so this is the normal 1,2 addition of carbonyls that we've seen in the past. Some nucleophiles actually do a 1,4 addition. And that 1,4 addition, the nucleophile will attack the 4 carbon. All right, let me switch colors here. All right, so what's going to happen is we'll attack the 4 carbon. These electrons will come up to form a double bond between 2 and 3, and then those electrons will go up onto the oxygen. And what we're going to get for the 1,4 product initially is going to look like this. My nucleophile will come in. This will be the 4 carbon. This will be the 3 carbon. I form the double bond here, and I have the negative charge, the O minus, on the oxygen. And when I treat this with acid, this is just an enolate. So when you treat an enolate with acid, what happens is it'll protonate at the carbon, and what you'll wind up with is just the carbonyl compound. So the nucleophile will add 1, 2, 3. It'll add at the 4 position. Okay. Notice I have the resonance structures for the alpha-beta unsaturated carbonyl compound shown right here. And if we go through and number these, we could see 1, 2, 3, 4. 1, 2, 3, 4. The positive charge where the nucleophile is going to attack is at carbon 2, where there's the plus charge, and at carbon 4, where there's the plus charge. All right? So the order of the additions both make sense. So why do I get one versus the other? Okay, the normal types of nucleophilic additions, the 1,2 additions. What I'm going to have for those is a strong nucleophile. And what I mean by strong nucleophile, whereas all that negative charge is localized on the carbon atom that's doing the attacking. So things like Grignard reagents, where I'll have, let's say, CH3 MgBr, right? Where essentially what I have in this Grignard reagent, this is the equivalent of just a CH3 with a minus and the MgBr plus. So all this negative charge is localized on the carbon, and those will do the 1,2 additions. The other ones that we've seen are the alkyl lithium, so something like butyl lithium will also give 1,2 type products. For the 1,4 products, what we're going to use is conjugated ions. So ions that are a little weaker, right? They're not as strong. So instead of weaker, let's put that in quotes, let's just say delocalized. So things like cuprates, right? So if I had a dialkyl cuprate, this would be a softer. This isn't as ionized, and that would tend to add in the 1,4 fashion, and something like a stabilized ion. So if I have something like a disubstituted carbonyl compound, right, where I have the anion here, that's going to tend to do the Michael type addition. So anything that's conjugated, even enolates will tend to add 1,4 instead of 1,2. They'll do that 1,4 addition first. But the more stabilized it is, the more we're going to guarantee that we get that 1,4 addition product. So again, let's just go over the mechanism on a new slide. That 1,4 addition, all right, let's use this, and I'll just use a stabilized anion. Let's do ethyl malonic ester, right? Because we use this in the malonic ester synthesis. But I'm going to make the anion here. I have the negative charge, and what that's going to do, instead of that 1,2 addition, this is a stabilized ion, conjugated. It's going to give me that 1,4 addition. And what I'm going to get is first the enolate. Let's see, so, and then I got to put my carbonyls on here. Okay, and then treatment with acid. Going to reform the double bond and take that proton, and I'll wind up with the carbonyl.